In this video we're going to look at some of the Educake questions, looking particularly at areas such as homologous series, separation, cracking, combustion and bonding. Once you've watched this video, go back to your Educake and look at these questions and see how you did on them as to which areas you need to focus on for your dirt activity. Okay, so to start with, I want us to think about what that word homologous means. So we can break this down into two words. So homo meaning same, and logos comes down to being ratio or proportion, that logic going on there. So if it's talking about a series with the same ratio, this is telling us that it has the same general formula. So for alkanes, we say that for every carbon atoms there are twice as many hydrogen atoms plus 2. So for example, butane, we have 4 carbon atoms, so then we know that carbon is C4, and then for our H we have to do 2 lots of that 4, which is 8 plus 2 to give us 10. But they all have the same general formula, and so for our alkanes, the next one in the series, we're adding on CH2 for each succession, for each successive member of series. And we can also think about this a bit in terms of our groups of our periodic table. So as we go down our groups, we end up increasing size, and the same thing is happening if we're adding CH2 each time as we go through that sequence. We're increasing our size. However, our reactivity in our groups is the same, so our chemical properties are similar. However, what we notice in our groups is that our melting and boiling points, we have trends in those. So with our physical properties, there are trends. With our alkanes, which we'll deal a bit with covalent bonding later on, but we have our boiling and melting points increase as size increases. Thinking about different ways in which we separate or get different molecules out of what we put in. So physical separation, this requires us to use physical properties to separate. Different examples of physical separation methods, so you've got filtration, distillation, crystallization. They're all different physical separation methods that you will have looked at previously. In terms of our crude oil and fuels topic, we're talking about fractional distillation, as they're being separated based on their boiling point, which is a physical property. Whereas if we're talking about chemical separation, we're talking about breaking bonds and there being a chemical reaction happening. And in the context of this topic, this is where our cracking comes in. Covalent bonding, so this word co means that we're sharing electrons. I'm going to start off simple with our methane, so it's CH4. This is our smallest of our alkanes, and each hydrogen has 1 electron and carbon has 4 electrons. So altogether we've got 4 bonds between our carbon and each of our hydrogens. Now this is quite a small molecule, however it will have interactions with other molecules of methane. So this is just one molecule. However, we have forces between molecules, and this is what's overcome when heating. So in order for our methane to go from being a solid to a liquid, we're overcoming forces between those molecules in order to make our molecules be further apart from each other and have more movement, more kinetic energy. And then going from liquid to gas, again, it's those same forces between the molecules that we're overcoming. These are very weak forces and therefore require little energy. However, no covalent bonds are broken when we're doing this. Our covalent bonds are very strong. They would require a lot more energy in order to break, but the forces between our molecules that are needed for those transitions solid to liquid to gas, they're very weak and very little energy, and so they have relatively low melting and boiling points. However, as our size of our molecules increases, we have stronger forces between our molecules. So these increase with size, and therefore we'd expect more energy to overcome those forces, and therefore our melting and boiling points are going to increase with size as well. Combustion, we are talking about burning in oxygen. However, our products vary depending on whether we have a plentiful supply, so lots of oxygen, or a limited supply. In our plentiful supply, we end up forming carbon dioxide and water, whereas when we have a limited supply, often we form carbon monoxide and water, but sometimes we only form carbon and water. But they will tell you, because carbon is a solid, whereas carbon monoxide is a gas. Carbon dioxide is also a gas. But thinking about our symbols, so carbon dioxide is CO2, carbon monoxide is CO, and carbon is just C. Where we've got lots of oxygen available, we've got lots of oxygen being able to bond with carbon. Where we have limited amount of oxygen, we have fewer oxygen atoms bonding to each carbon. Carbon dioxide is obviously a greenhouse gas, as is water vapour. Carbon monoxide, however, is dangerous to us, so carbon monoxide poisoning happens, where the carbon monoxide bonds to the hemoglobin instead of oxygen, and that means that you've got less oxygen being supplied around your body. Carbon as soot, we've looked at in atmospheric pollutants, that can also trigger asthma, as more air particles causing poor air quality. Turning now to cracking, which we established earlier is a chemical separation, as we are breaking bonds, as we are breaking down large hydrocarbons into smaller, more useful or more in demand hydrocarbons. So for example, if I take 1, 2, 3, 4, 5, 6, 7, so I've got C7H16 to start with, and what I could do is I could break any of these covalent bonds. So we're breaking our CC bonds, and we are always using heat in order to do this, and so we would call this a thermal decomposition reaction, as we're using heat, so that's the thermal part. Decomposition is your breaking down. So cracking is an example of a thermal decomposition reaction. And when we break down these bonds, we will break it down in order to form an alkene. So that has a CC double bond and a shorter alkane. So we end up forming an alkane and an alkene. But depending on where the bond breaks is going to depend on what products we get. In an exam, they will often give you one of the products and then expect you to work out what the other product is. But all you need to remember is that your number of atoms need to be conserved. So here we've got C7H16, so when this breaks down, we're going to still need there to be 7 carbons in existence and 16 hydrogens in existence. How many of those are in your alkene and alkane is going to depend on what the first products you were given. In your dirt activity, I've just asked you to be able to give me an example of how decane, so C10H22, could be cracked. So for that, you can just break it down however you like, so long as you're making at least one alkene and one alkane. Also note that the alkene tends to be smaller than the alkane, so a shorter hydrocarbon for our alkene and a longer hydrocarbon for our alkane. So look back over your Educake, see which questions you didn't do so well on from the ones that I put on the front slide, and then decide on at least one of these dirt activities to complete and submit your answers to these in teams.